We are going to have our session 2 today on Lean Six Sigma. Just to have a slight recap, last time we have opened our session on Lean Six Sigma and then we have detailed in on the Lean part of it. Today we are going to have more details on Six Sigma. So who are joining the session first time, already my Lean video is available on my from our previous session. It's available on my YouTube channel. You will see the same banner on my YouTube channel, so you can see that Lean. But not to keep you very empty on the subject, so I'm just going to refer something now so that you can understand the Lean also. See, actually, Lean Six Sigma and all is not something very new in the industry. They are basically from the concept of optimization management. You need to optimize everything, because if you don't optimize, that means you are wasting your resources. You are not doing great in your processes. You are not making your job correctly. So that's why the optimization management teaches us to look into this concept. Lean Six Sigma is just one name, one methodology. You may be doing it with some different name, or maybe doing it without name also. And why I'm telling so? Because when you see on your screen right now, Lean and Six Sigma breakup. So Lean indicates that reduce the waste by streamlining the processes. You must reduce your waste. So when we do our processes, when we do our manufacturing, when we provide our services, we always try to reduce the waste. And in my session, when you will see recording, you will understand on my channel that waste could be anything. It could be a motion waste, it could be a time wastage, it could be a money wastage, any kind of wastages. So we should avoid that. Now coming Six Sigma. Okay. So what is Six Sigma? In Six Sigma, we want to reduce the defects. When I'm manufacturing something, in that manufacturing process, there could be a wastage. And that wastage is happening. One of the reasons for that wastage is I'm manufacturing defective products. So we try to avoid that defects in our manufacturing or defects in our services what we are providing to our customers. See, avoiding the defects, reducing the defects is not the only concept that, oh, we do great, we make our products very accurately. It's not only up to that limit. This is only one aspect of it. But at the same time, when you reduce the defects, that means you are giving your customer a much better product. And we'll see how it could impact your customer-centric approach, or how it could attract your customer towards your product when you are ensuring that your products are much lesser defective or without defects. This helps in building your brand image in the market. Generally, when we buy some products, correct? So what is one of the criteria? We buy some products blindly. Today, tomorrow, after 1 year, 3 years, because of one confidence. That manufacturer is not compromising the quality of products. You buy today, tomorrow, after 1 year. That confidence to the customer comes from where? Because the manufacturer is so committed, so sincere to make a quality product that whatever happens, I will not give the bad products to my customer. Correct? But at the same time, if manufacturer is so strict about his quality, that means any defects happens, he will remove that defective product, he will recycle or whatever he will do, and he will sell only good products. So look from manufacturer point of view also. He is very choosy to give right product to his customer, there is no doubt about it, and it is a very good approach to build his brand image in the market. But at the same time, if the defects are more, and manufacturer don't want to give defective product to his customer, see, those defective products will be a financial burden on the manufacturer, correct? And if that financial burden is there on the manufacturer, his cost of production will increase, and in turn he will become non-competitive in the market. He will not able to compete with his competitors. So he need to give good products, flawless product to his customer, very good approach. But at the same time, to make that, he should avoid the flaw in his own house also. And when he remove his flaws, he is able to produce very minimum amount of defective products, so that it is not impacting his cost of production also, and his customer is also happy. So these concept of Lean Six Sigma, they make your house good as a manufacturer. They satisfy your customer also. So it impacts internal environment inside your organization and external environment also, which is called society, customers, ambience. Because see, every customer may not buy your product every day, but the customer who purchased it today, the product, he should speak good about it for years to come, so that he will trigger, it will trigger another customer to buy your products. And it only comes when you are ensuring right quality, consistent quality in the hands of your customer. So you have a very simple picture in front of you, but it is a very critical picture, okay? And why it is critical picture? It looks simple, but it's critical. The organization, the product comes to your hand. A piece of bread, when it comes to your plate, some farmer, some part of the world had a courage to grow 1 grain of wheat. Correct? See the journey of a slice of a bread, a piece of a bread. Similarly, the cloth what you are wearing right now, somewhere raw material has been produced. If it is cotton, it's from the agriculture land. Silk, again from the agriculture land. If it is synthetic, it's still generated from the some downstream companies, petrochemical plants, synthetic fibers. That fiber comes to a manufacturing garment industry, where garment industry make a cloth out of it from that thread. Okay, they dye to the different colors, they make a cloth. From that cloth, they make the different garments, shirt, pant, jeans, okay, all garments. Then they are packed and then they are sold in the market. The most important point here, what I'm trying to make is, you have multiple places to do mistake. The quality of cotton was not good, which has been purchased. So that's why the thread which has been made out of the cotton is not good this time. Getting my point? From the petrochemical plants from where you are polyvinyls and which are fibers you are buying, probably this time there is a quality issue in that. So it's not able to, the cloth which you make is not able to sustain the iron. The dyeing, which makes the colorful clothes, correct? The pattern of dyes are this time not working, the quality of dye is not good. So the cloth which have been colored to your desired designs, patterns, correct, is losing its color early in a single wash. The cutting of the clothes, automatic machines are doing some malfunction. So the extra large size used to have a minimum defects, this time defects have increased. So this extra large size, they are not able to maintain one particular size, and the defects are coming a lot in the dimensions. Somewhere it is going 1 inch off, somewhere it is getting little tight, somewhere it is getting like off shoulders. Any problems? Okay, even after that, when you made it very good, your packaging material was very bad. So the clothes, when they were packed, they damage your clothes. Packaging and logistic concerns. Then it's going to the market. So finally you see how many risk factors are there in the product life cycle. If the input of your cloth itself is bad dye, is losing the color, whatever effectively you manufacture, What is the accuracy of your manufacturing? But if the closed processes are interconnected, you cannot say that I fixed this portion, this is working fantastic, very good, so now total product is fine. No, it cannot be said. That is where the Lean Six Sigma. Okay, now we are completely on board with Six Sigma concept. Okay, for some time forget the Lean. Okay, we are talking only Six Sigma now. What you see on your screen, and it is a very good, interesting slide which I have prepared specially to understand the Six Sigma concept. Okay. What you see on your screen right now, go very slow, no hurry. Okay. You are a manufacturer who is making the. I will just indicate you here. What you see here, okay, that will make your customer happy. By the way, that emoji is for happy, huh? Okay. So the customer is happy. Any bottle which is rejected by your customer, maybe because of you are not able to maintain the special perfume. You see a number coming on your screen now. Okay? And this number is giving a number called 993790. So now this much bottles are acceptable to your customer. That means there is some maybe concentrated, some dilution impact happen, some defects happen. Okay, let's take that way. So your 6,210 customers rejected your product, or in that I will say some product you rejected in your quality, some your customer rejected. So finally you have 6,200 bottles are rejected, which is almost 0.6% of your production. So this is a loss to you, okay, in the statistics. And what does this bell curve says that whatever this number 993,790, all what is not good, which are bad, are outside here in this area. Is a good one, having no defect, or sorry, no defect. There is a center line for no defect here, but minor variation is there, but that variation is acceptable to your customer. So it is within your customer satisfaction limit. But outside, tell me, do you feel that you can accommodate 6,210 defects? And okay, one time it happened, fine. But if your everyday perfume bottle manufacturing is 1 million a month, so that means your profit margin of a month will reduce by 0.6 directly. So now as an owner, you will start seeing the things. Check what happened, why our perfume combination is not correct, or we are mixing 2-3 things in our perfume. Try to check individually which component, which chemical in our perfume, A plus B plus C plus D chemical. So this A chemical is deviating from the required quantity specification. Now you fix that problem. Very good. Now you are testing it, your product quality is coming consistently good and everything good, okay? By your this efforts, what happened now? See the next scenario now. 999, that is 999,996 points increased. Okay, only 3.4 bottle, 0.0003%, nothing. Correct? And see how the bell curve looks now. Only this one. All is good here. Okay? Up to this point, clear, correct? Good. Let me just delete here, guys. Okay. So now there could be another reason also. Your bottling machine was making some issues. The bottling machine had some packaging unit had some problem. So that's why your packagings were getting defective after every. We have discussed today in this slide 2 sigmas. By the way, 6 sigma. Similarly, you have 5 sigma, you have 4 sigma, you have 3 sigma, you have 2 sigma, you have 1 sigma. But 6 sigma is minimum defects. It is the journey of reducing the defect. As you reach in the ladder up to 6 sigma, you have only 3.4 number out of 1 million number defects. So this is a journey of reducing the defects. How? Through the process. and it's a continuous process. Oh, I fixed it. Just to give you a pictorial explanation of what we discussed in the last slide, Six Sigma goal is to reduce process variations. Process are not working correctly. After every 1,000 pieces, machine is producing one. Simple example. See here. You can see the lining. See the lining here, defective piece. There's no lining here. We had a process variation. There is an issue with CNC machine. There's automatic machine, so there is a wide variation. If you say these are three different patterns, fine. But if they are not three different patterns, they are supposed to like him, then correct. Then you see, you get the same pattern. These are the corrected patterns. Approach of Six Sigma, and it is completely industry based. It is completely the action of Six Sigma is based on nature of industry. Should we go for Six Sigma, or we are okay with 4 Sigma, 5 Sigma? This also we will discuss. Okay, this also we will discuss. But because going for certification or you are not going for certification, Lean Six Sigma is a philosophy of handling the wastages, handling the make a basic understanding on the subject. You need to do your detailed curriculum. You need to study your detailed curriculum when you are going for certification program. But this is just building up a basic foundation for your clarity and understanding. So respect your curriculum, what you are doing for certification program. My sessions are not assisting you for any certification program. A very small write-up. You are going to get this, so don't worry. I'm just going to read what is the Six Sigma approach now. The facts. So this is a fact. Processes are interconnected. Nobody works in isolation. Variations exist in all processes whose characteristics can be measured, analyzed, controlled, and improved. Yes, there will be variations. When you do a crop, simple example, a farmer cannot guarantee that the wheat in size will be same as it was in the previous crop. Okay, this variation will exist. Temperature conditions, pressure conditions, ambient conditions. But what you should do, these variations you should measure. You analyze them and try to control them. Suppose the mine from where you are taking the ore is changing its characteristics. You need to come. Things are interconnected and there will be variations. There is no foolproof system which says that no, there will not be any change. Everything will be perfect as it is from A to Z. No. So these are the facts. Understand why it is changing. If it is a natural variation, fine. But if it is not a natural variation or it is not the desirable variation, you must have the analysis done on that and you should try to correct it. You give a consistent product, you are able to manage a high degree of customer satisfaction, and you are able to manage the brand image in the market. Great. I always do the right thing. Six Sigma methodology focus on improvements by managing variation and reducing defects in processes across the enterprise. For example, as I said that in our industry, because of that your steel is, now you define that problem. Okay, that there is a problem at a particular level in that process. Cotton grade has changed. Any example you can take. Even the mineral waters, what your bottling plants, what they are manufacturing. Even the chemical composition, calcium, magnesium, potassium. So when you measure it, after measuring it, what you should do? You analyze it. It's not happening correct. This particular machine is giving me a problem. Try to fix that machine. Either that machine is very old, so try to deal with that. Try to bring the new one if you want, or try to improvise that product or that machine. Your job is done. So by this process, when you are doing it, you had a high variation. You had a high variation here. So from there, after doing this cycle, define, okay, analyzing, improving, monitoring, your defects are reduced. Now you have come to a safer zone. Your product defects have reduced. So this is what the things scientific approach works. And remember one point, this is a data-driven process. You are handling with lot of data here. Qualitative analysis works very good for a longer duration. But when it comes to reduce the defects to that level, 3.4 defects per million in Six Sigma, it is more numerical driven, data driven, feedback driven system. So all the examples from all the industry today so that you can be clear what is the subject we are talking. Six Sigma methodology is a proven data driven structured process improvement methodology for sustainable business improvement driven by business and customer expectations. One very simple example. You know that you are putting a label on your when you pick up the bottle, correct? So you have a label here, okay? In this label, I just put a picture here to see you. TDS 180, calcium plus 36, magnesium 4.9, and so on. pH 7.5. So it's alkaline in nature. What is our idea behind this? The bottling plant has to ensure that these quality parameters, which are certified from the respective authorities, you are able to manage these quality parameters, composition in the water. If you go beyond this, you are not only defaulter from your clients, customers or consumers, you are even defaulter by the government authorities also. So it could have a bigger impact on your factory and manufacturing. They may seal your production even. So why to go to that extreme condition? Better keep monitoring these parameters. And that's why these parameters are monitored on regular basis. And there are systems, if they are less or more, to remove them or to add them so that you can balance out. It's completely focused on the parameters. If you are making a t-shirt, do not make a shirt. Okay? So make sure the specification of t-shirt what you are manufacturing, you continue manufacturing of the same specifications. If you want to change the design, it is beyond the scope of Six Sigma. Six Sigma says what you are manufacturing, you manufacture correctly with minimum defects. And the total Sigma family, in fact. Same example from the cement industry. Six Sigma measures process variation that cause defects, unacceptable deviations from the mean or target. Getting my point? Generally, the cement industries are somewhere in the hill. Okay, they are located near to the raw material, limestones. In general, okay, in general. Because that raw material transportation is a big headache, and it is better to be remain with that raw material, so that because raw material comes in a different shape, so transportation logistics could be some of you may be from the cement industry who can highlight that very well. I'm not from the industry, but I know it. Okay, so the point here comes, if you are sometime what happens, you are manufacturing 3-4 grades of cement, but now you saw over a period of time your raw material is changing its quality and its pattern, which is coming from the mountains when you are taking it out, limestone mountains, okay. So what you do, you decide to discontinue 1 or 2 grades. That is what I know, but if you are from specialist from industry, you can tell me. So why you discontinue? Because that limestone mines, that limestone raw material source mountains which are there near to your plant, you are not getting that quality now. So this is one concept. So input has changed. Second is the packaging mechanism. So you are ensuring that if you are making a cement bag of 20 kg and if the defects happens, now see, this is an interesting case. Huh? If defects happens and last 3 months you are not even noted, but what is happening? Your every batch, that packet is giving 20.5 kg of cement to your customer. Your customer is very happy, by the way. But you are not aware. Even 20.1 gram, 100 grams extra, customer will be happy. But you will be at loss, correct? And you are making this loss continuously. Just because a small error in your process. And similarly, other way around, if your packaging is going unnoticed, to 19 kg and 900 grams, 100 gram less. Immediately you'll get a complaint from the market that so and so brand of the cement, they are giving the quantity of cement less than the defined one. Either way, in the modern era, these things are very strictly monitored now. But just to make you understand the concept, I'm giving this kind of examples. Okay. Otherwise, nowadays, so they will sue you. Okay. If you are what defined quantity you are not doing it and you are giving it, so it's a different case altogether. But what I'm trying to make a point here, that these checks and balances have come so well in place now, whether it is in the name of Six Sigma or other quality management system, it has come so perfectly so that such kind of errors do not happen. So that's why it proves that we need this kind of quality checks and balances in our industry. We have done good about garment industry, and these are a very good picture of the garment industry which is there in front of you right now. They are minutely, there is in the yellow, here you can see what is written. Systematically managing the variations to eliminate the defect. Systematically managing. Stitching error is there, try to see which machine is creating an issue, take out this machine for maintenance. Sizing issues are happening, look, is it where the problem is happening, try to see that, try to fix the automatic cutting machines. Okay, so these are here, and these are systematically, database analysis is done, so that from 3 Sigma your journey continue towards 6 Sigma, reducing the defects. Okay, I am 6 Sigma and I have only 3 million defects in my box. So 3.4 defects per million in my box. I'm very happy. It's fine. It's fine. It is not only restricted to defect control. Yes, that is a primary thing to reduce the defect. But is your product is able to meet the continuous customer satisfaction? Or I'm triggering two important factor here. Be with me at this point of time. Means I'm going to change my position now slightly. And what is that exactly? That good, 3.4 million defects, fine. 3.4 defects per million. But because of this, my product cost is going high. It is making a burden on my customer's pocket also. So I am bringing a concept on the subject that you, before you go to the 6 Sigma level, to achieve that much accuracy of production or the minimal defects will be requiring lot of monitoring. Probably your investment cost of your manufacturing will be very high. Okay, and probably your product cost will be very high. Is your competitors using 6 Sigma at this point of time or not? And take this point. After the next slide, I will again reopen this subject for a minute. Let me go here. Then I'll come back to that slide. 6 Sigma increases the cost of product. It's true. Because when you go to that level of accuracy, definitely you are not allowing any defects, visual, tested, to continue to pass on. No. There are some good brand purse are there. Okay. They are costing very high. There are brands which are costing very high. But when you take their product in your hand, you feel that a worth has come in your hand. They are so meticulously crafted, they are so meticulously tested, and they are consistent in the market with their quality for last 10, 15, 20 years. They are still maintaining the quality. Their hooks, their small component in their products, no compromises. All the ladies on the board will appreciate me by seeing this example. There are purses so well managed from the design perspectives. They are very costly, but their qualities are maintained very well. Even if you hold that for 5 years, 10 years, they maintain their quality. So the Six Sigma has a cost also. Now you'll ask me the question, Nitin, we have a bottling plant, correct? Water bottling plant. What if the more bottles get bad, or if I have more, more rejection? It's water ultimately, okay? So we can manage with more defects. I can recycle that and everything. So you are right. The decision of going to Six Sigma, if I'm making a Ferrari, okay, and if it costs me one defective Ferrari in a day, and I'm producing 5,000 Ferrari or 1,000 Ferrari per day, one Ferrari rejected or defective will cost me heavily. So I need to have the Six Sigma in place. I need to have that kind of system in place. That's why automobile industries are following Kaizen, Toyota, production management, TPM. These are all concepts. Many of the concepts have flown from the Japan. That level of accuracy. So it's a judicious decision when you are doing a startup. Does your industry need that level of accuracy, or you can still manage with 3 Sigma, 2 Sigma, 4 Sigma? That's industry based, because ultimately you have to be competitive in the market also. So this was a point which I wanted to share with you, that Six Sigma is not a fashion, it's a need. And when we say need, when it is required, it is required. When it is not required, not required. That level of accuracy. We'll talk on Kaizen now. Kaizen is another concept, and Kaizen is a concept which is continuous improvement. Okay, and this is the best example what you can see on your screen right now. Progress from a simple, unrefined state to a more advanced and sophisticated one. Continuous improvement, you can see. Where we are today is not end of the day or end of the business. No. You have to see more improvement. Continuous improvement. This is how all the industries are evolving. They are continuously trying. Speed, road speeds, products, product quality. So Kaizen is the concept which is attached to Six Sigma. Look for a continuous improvement concept. Kaizen. These are the we are almost coming to our end of our session, and we have a quiz now, online quiz. So I know you guys are participating. These are the different certifications: American Society for Quality, International Association for Six Sigma certifications, Council for Six Sigma certifications. So these are all accreditation agencies which give a certification for Six Sigma belts and different belts they are giving it. So if you are willing to take that, you have to get connected with the respective institutions which will give you coaching for these certifications, black belt, green belt, okay? So take that program and go for certification. If you are from the Six Sigma, you are willing to take up the Six Sigma belts as they require. So now it's quickly quiz time, okay? So we get into the quiz program now.